Hello ladies and gents, my name is RProg and welcome to another C++ tutorial. And in this one we're going to be talking about memory allocation, and if I have enough time, I'm going to be talking about file input and output. Now, to kind of save up on time, I made a little doodle because we have to talk about the stack and the heap. And if I'm not careful, I will over elaborate on the stack and the heap and drag this video about 5 minutes too long. So essentially, this is a good example of the stack and the heap. This tends to be an average size, and of course this may not be the maximum size, and that tends to be the minimum size of the stack size, but you guys in the comments can leave your comments if it's smaller, if you've heard of a smaller stack size or a bigger stack size. And most of the time, but then depending on your environment, you can actually set your stack size. And it also depends on your architecture, whether it's 32-bit or 64-bit. An easier one to explain is the heap. It's simply the amount of physical memory you have installed in your system that's being managed by the operating system minus the amount currently being used. For example, if you have 10 gigabytes of RAM installed in your computer and your operating system's running and it's using 2 gigs and you have 8 gigs that are not being used, the 8 gigs is your heap size. So your heap is vastly bigger than your stack. Your stack is essentially there to act as a backbone for your program. So let's see how to utilize the stack and the heap. Let us say, well, first let's just declare something on the stack. Well, looks pretty familiar, right? Now, in order to declare something on the heap, we need to, well, in this case, I'm going to declare a raw pointer. I need to learn to type. And then we're going to use another keyword that's known as new. I didn't want to say a new keyword, new. Anyway, after we use our new keyword, we then type our data type. So, what this does is this tells C++ that you want this pointer declared on the heap, or allocated to the heap instead of being on the stack. And this is here to essentially give the size that it wants to ask or needs to ask the operating system. So a good way to remember this is the promise. Anytime you type the word new as a keyword, your program looks to the operating system and says, I promise you, I will give this back if you give me 4 bytes. Now, you can use the size up function in an output statement if you want to know if the integer is actually 4 bytes or not, things of that nature. Look up cppreference.com or c++.com. It talks about the size of the function there. Excuse me. So let's go and assign a value to that and then output both those guys. Alright. And we're getting 10 as expected, but we still have a problem. We are encountering something known as a memory leak. We can use, in Linux, we can use something known as Valgrind to detect these annoying memory leaks. And as you can see, it is definitely detecting those 4 bytes, which is the size of our integer. And the reason why is because we didn't make good on our promise. We allocated 4 bytes to the heap, but we did not deallocate. So in order to deallocate, keep our promise, we need to delete it, or use the delete keyword, and you simply use the name of the pointer. Now, another good way to remember it is if you knew it, delete it. My college professor said it that way, and that pretty well stuck. So we can go ahead and test this theory. And as you can see, all the heap blocks are freed. We no longer have a memory leak. Now, one last thing I need to show you before I get into what's known as smart pointers. Let us see what it looks like with an array. I'm going to throw 9 zeros in here. 7, 8, 9. Now, we already know an integer is 4 bytes in memory, so you take this big long number and you multiply it by 4. That's how many bytes you're using. All right. I'll just do done for now. I was going to show you a good way to check the size of an array on the heap, but we'll cross that bridge when we get into classes. Alright, that's what we wanted, segmentation fault. Okay. I know that seems weird, but bear with me. Okay. Now, we ended up with a segmentation fault, but we don't have any leaking memory or anything like that, but you do have access violations. This is what a stack overflow looks like. Essentially, I mean, you can tell by the number of zeros that are sitting there. That's probably quite a bit bigger than the probably 6 to 8 megabytes of stack size that you have. So that's no bueno. That will not work. So let us put that on the heap instead. So we'll declare us another raw pointer. So we'll use the index operator to say that we have 5, 6, 7, 8, 9. I think 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good deal. We'll use the index operator to tell C++ that we need an index of however big that daggum number is to be declared on the heap. And in order to deallocate it or give all that memory back to the operating system, we need to use the delete keyword again, but we need to use it in a different way. Instead of using delete by itself, we need to explicitly tell C++ that we're deallocating an array. And that's how you do that. And you still use the the array variable name, because essentially if you just access, if you remember, I believe I showed it in a past video, if you just try to access the array itself, you're going to get back the first element. So that's how that works. You can just use the array name, and it's essentially like giving a pointer. Here we are. I'm sorry if I seem like I'm out of it, guys. I did not get any sleep today, so it has been rough. But I've been bound and determined to get this stinging video uploaded and made for you guys, or whomever's watching, or however many of you's watching. Okay, let's get into the smart pointers. Alrighty, there's 3 different types of smart pointers. I'm not going to explain it all to you. I will let you utilize CPP reference or c++.com to look all that up. But there's a weak pointer, a shared pointer, and a unique pointer. We're going to use a unique pointer in this example. The big difference between the two that I use the most, which is the unique and shared pointer, it's a unique pointer takes complete ownership of the memory address that's being allocated to the heap, whereas a shared pointer will share ownership. So here we go. Did I forget it again? No, I guess it's just... That's weird. Huh. Color scheme must be not allowing that underscore to be showing. Well, at least that's how I hope is what it is. Okay, that must be it. It must be a color scheme thing. So there's different ways to allocate a unique pointer to the heap. I'm going to use something known as a reset method. So we'll just go ahead and declare a unique pointer. These objects are templated, so we need to tell C++ what type of unique pointer it's going to be. and then we simply declare it. And then I'm going to use the reset method, which it looks like a function. It's essentially a function within a class. We'll cross that bridge soon. And I'm going to simply allocate it within the reset method, and then use brackets or parameters to assign the integer. I'm using the integer constructor right here. Something else we'll get soon. And then from there we should be able to output a dereferenced unique pointer, and that should be all she wrote. Alright, so we got the correct value. We also have all the heaps block free. Now notice I'm not using the delete keyword in this whatsoever. This is because when a unique pointer goes out of scope of wherever it's declared, it will deallocate itself. So this is really helpful with when we get into classes. It's still helpful within structured programming for functions and such, but once that function hits the end of its scope, it's going to deallocate itself and then not be accessible within main. So you have to be really careful about where its functionality ends. These things really shine within objects. Not that it's not useful, like I said, in functions and things of that nature, but yeah, you guys will see. I will cross this bridge again with the unique pointer. All right. Well, let's see here. I don't think I'm going to have enough time to cover file input and output in this one video, so I will make another video. The next one will have to be over file input and output, and then finally we'll be touching base on classes as well as structures. So with that, guys, I hope you enjoyed the video. If you did, please like, share, and subscribe. And if I made any mistakes, please leave a comment below. And I apologize for the delay for this video, because I've been dealing with a lot of personal issues in life and dealing with medical issues and issues such as lack of sleep. But that's part of life. So guys, I'd like to thank you for watching. So bear with me as I struggle through all this stuff that's called life. And I promise this will get a lot better once we get into classes. This will get a lot more fun. So all I have to say is happy coding. And once again, thank you for watching.